Given to you is alpha and beta are roots of this equation. Very easy, you can figure out what are the roots because you know how to solve the equation. But what else do you know? Quickly looking at that, you know that alpha plus beta is minus b by a. So it would be what? It would be 1. And alpha beta will, right? So c by a is c is negative 1 and a is 1, so negative 1. So these two things we can write it down. And now for all positive integers n, they have defined an to be like this, b1 is this, and bn is defined to be like this. Let's look at what we have. So they are looking for which of the following options are correct. So the bad news is that every each you have to go to each and every option and check whether it is correct or not. Okay. So let's do it quickly. Go first one first. Let's go with the A part. Maybe that is helpful with the later one. We don't know. Let's see. So it says that you have to see whether a1, a2, and dot 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 an is equal to this or not. Okay, so let's see. The formula is given. An is alpha to the power n minus beta to the power n. So what is a1? Alpha to the power 1. Okay, minus beta to the power 1 upon alpha minus beta. Okay. Now you see alpha minus beta doesn't have a n in it. Okay, so it will be with everyone. Okay, so I will just take it out. Okay, so this is the first term. The second term would be alpha square minus beta square divided by alpha minus beta. We have taken it out. Okay, so just keep on going like that, and the last term I'm going to write like this. Okay, so now you can see it's very simple, right? What? Because you're getting a GP, because you have taken alpha minus beta has nothing to do inside. Okay, so you end up in getting a very simple GPs. Okay, this is alpha to the power n, and another GP you are going to get is beta plus beta square and dot 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 beta to the power n. Okay, very simple, you can solve it now. Okay, so what is the sum of GP with n terms? You can clearly see that there are n terms. Okay, a 1 minus r to the power n. Okay, so r is alpha power n upon 1 minus alpha. Okay, similarly the other one b. Now what do we get? 1 over alpha minus beta. You see what is 1 minus alpha from here? 1 minus alpha is beta. Okay, so let's write that this is beta. Okay, and what is 1 minus beta? Again from here 1 minus beta is your alpha. Okay, so this is my alpha. Let's have it like that. Okay, beta 1 minus beta to the power n. Okay, now what more I can do is alpha upon beta, you see. Okay, I can just multiply alpha upon beta inside. Okay, you get alpha upon beta minus alpha n plus 1 upon beta. Okay, similarly the other two terms, beta upon just arithmetic. Okay, you have to choose just computation to get it. Let's somehow power alpha n plus 2 and beta n plus 2. Okay, let's do that. N plus 1 upon alpha. Okay, now let's try to aggregate things. Okay, this term and this term we will try to club together. Okay, because they are of course not contributing to n plus 2, right? So this minus beta upon alpha. Okay, that's one step. And then minus alpha n plus 1 upon beta minus beta n plus 1 upon alpha. Good. What next? Yeah, take LCM. Yeah. Okay, so alpha minus beta. Okay, here you have alpha beta. You know what is alpha beta, right? Okay, anyways, let's write it down. Okay, this is what you get. Okay, minus what else? Again, alpha beta common. You see, what are we getting? Okay, alpha n plus 2, right? Alpha n plus 2 minus beta n plus 2. Correct? Okay, that's what we wanted. Okay, anyways, now let's see. Alpha beta is minus 1. Okay, so I can just replace alpha beta by a minus 1. Okay, and alpha square plus beta square, you can always write it like this, right? Okay, minus again alpha beta is minus 1, so I make it a plus. Okay, alpha n plus 2 minus beta n plus 2 upon 1. Okay, now alpha minus beta I will multiply inside. What are you left with? Minus alpha plus beta, right? Okay, plus, okay, what happens? Alpha n plus 2 beta n plus 2 divided by alpha plus beta. What is that? An plus 2. Okay, so that is an plus 2, and alpha plus beta anyways you know it is 1, so you end up in getting an plus 2 minus 1. Okay, so after doing this much work we know that the first one is true. Okay, let's do another one. That also will need little of a work. An upon 10 to the power n. Okay, summation is there. Okay, we have to show how much is that. So what I do, I'll just plug in. Okay, n is 1. Okay, this is my series which I'm getting. A1 upon 10, A2 upon 10 square plus A3 upon 10 cube, right? And this is an infinite series. You see, you are going up to infinity. Okay, so what do we do again? The same thing, same old thing. We are just going to write instead of A1, we will use this again. So what I'm alpha minus beta, right? N is 1 upon alpha minus beta. Again, I do the same thing. I won't drag alpha minus beta all the way with everyone. I will just take that common, okay? Upon 10. Plus A2 is what? Alpha square minus beta square upon alpha minus beta. I have taken that out. And then 10 square. Okay, this is an infinite series. Okay. Okay. You see what to do now? Quite obvious, right? Again, you're getting a GP. Okay, infinite GP. Alpha upon 10 plus alpha square upon 10 square dot 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 dot. What is another GP? Beta minus, sorry, beta power, beta upon 10, beta square upon 10 square plus dot 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 dot. Okay, now again quite simple. Let's write it here. I get 1 over alpha minus beta. And what's the sum of infinite GP? If the common ratio is less than 1. Okay, alpha upon 10 upon 1 minus alpha upon 10. Okay, the other one, beta upon 10 upon 1 minus beta upon 10. Okay, just need a little of a simplification and you're there. Okay, let's do that. One more step. I can cancel 10 because I can take LCM to be 10. 10 minus alpha. Again 10 cancelled. 10 minus beta. Again I will take an LCM. Okay, so let's do that. 10 minus alpha, 10 minus beta. Okay, what do you get on the top? 10 alpha minus alpha beta minus 10 alpha plus alpha beta, right? That's all you get. Okay, let's cancel things. This, okay. What are you left with? 1 over alpha minus beta and then 10 times alpha minus beta. Here, just multiply, okay? 100 minus 10 times alpha plus beta plus alpha beta, okay? Now this alpha minus beta gets cancelled. Let's cancel that, okay? What are you left with? 10 divided by 100. How much is alpha plus beta? 1. How much is alpha beta minus 1? What is this? 10 over 89. Okay, so after doing this much work, I know that the B part is also true. Okay, let's go to the C. So C is Bn. Okay, I have to show whether Bn is this or not. Okay, what they have given Bn to be. Okay, in our definition, Bn is An minus 1 plus An plus 1. Okay, let's write that. So Bn is An minus 1 plus An plus 1. Okay, I have to see whether I am getting this or not. Okay, so I will use the definition of An minus 1. What is that? Okay, again, alpha minus beta I will take out. Okay, 1 over alpha minus beta. Okay, alpha n minus 1 plus, no, it's minus, right? Yeah, minus beta n minus 1 plus alpha n plus 1 minus beta n plus 1. What I have to see, because they want like power n somehow. Okay, let's club things up again. Okay, so you have 1 over alpha minus beta. Okay, I will club these two. Okay, so I will club these two, alpha n minus 1 plus beta n plus 1. Okay, and then minus beta n minus 1 plus beta n plus 1. Good. Now I need alpha to the power n, right? So somehow let's try to take alpha to the power n outside. Okay, let's do that. So if I try take alpha n outside, what I am left with? 1 over alpha plus alpha, right? Here, I try to take beta to the power n outside, what I am left with? 1 upon beta plus beta, okay? Because I wanted alpha power n and beta power n, okay? That's all. Let's see what more. Okay, so what is 1 over alpha plus alpha? 1 over alpha plus alpha, how much is that? Over alpha would be minus beta and this is plus alpha, okay? And what will be 1 over beta plus beta? 1 over beta would be minus alpha plus beta. Because why? Because we know alpha beta is negative 1, okay? So this. So what do we end up in getting? I end up in getting alpha to the power n and here alpha minus beta, okay? And then minus beta to the power n, and what is this? Again minus I will take outside, okay? Alpha minus beta, okay? So very simple, alpha minus beta gets cancelled, you are left with alpha power n plus beta power n. Okay, so again, even C is true. Okay, so what's the probability that D needs to be true? Okay, let's see that also. What is D? Okay, so D is summation Bn upon 10 to the power n. N varies from 1 to infinity. We have to look for this series. Okay, so what do you have now? Let's plug in the values. 10 plus b2 over 10 square, okay, plus b3 over 10 cube, right? Okay. Now, can I use that Bn is same as alpha power n, beta power n? Definitely we can, right? So let's use that. Okay, so if I write Instead of b1 I'm going to write alpha plus beta, right? Instead of b2 I'm going to write alpha square plus beta square. This becomes simple. At least one part is helping the other one. Okay, so let's see. 10 cube. Again you can segregate the two gps. Yeah, you have alpha upon 10 plus alpha square upon 10 square. Similar thing had happened earlier. Okay, just that you had a, I guess, negative sign in between. Beta square upon 10 square dot dot dot. Okay, now just sum the series, infinite right series again. A upon 1 minus r plus a upon 1 minus r. Okay, now exactly the same stuff. Okay, shall I leave some step? Let's do it. Okay, plus beta upon 10 minus this. Okay, now I will try leaving a step here. Okay, so I get 10 alpha minus alpha beta. Okay, plus 10 beta, right? And then minus alpha beta upon, I will multiply the two, 100 minus 10 alpha plus beta plus alpha beta. Okay, now what all we have is 10 times alpha plus beta minus 2 alpha beta divided by, this was what, if you remember, that came out to be 89, right? Okay, now numerator, this is 10 minus 2 and alpha beta is minus 1. Okay, so I'm getting 12 by 89. Okay, let's check what were they saying. uh, okay, so this is not correct, right? They're saying 8 by 89, we got it to be 12 by 89, so one of the options is not correct. Okay, let's see another question. This was interesting.